Let us consider transformations of the form g of x equals f of x plus k, where k is a constant. To understand this transformation better, let us consider example. Let us consider f of x equals x square, which we know is a parabola. Let us take k to be equal to 1. When we get g of x to be equal to x square plus 1, let us plot the curve f of x. We know that f of x is a parabola. It passes through the point 0, 0, 1, 1, 2, 4. And it is symmetric with respect to y-axis. Hence we get corresponding point -1, 1 and -2, 4. This is the function f of x. Let us plot g of x now. G of x equals x square plus 1. So when x is equal to 0, we get g of x to be equal to 0 square plus 1, which is 1. Hence we get the point 0, 1 on g of x. So this point is on the curve g of x. Consider x equal to 1. We get 1 plus 1, which is equal to 2. 1 square plus 1, which is equal to 2. So we get the point 1, 2. This is 4, so somewhere in between we get the point 1, 2 on the curve g of x. Consider x equal to 2, we get 2 square, which is 4, 4 plus 1, which is 5. So for x equal to 2, we get it to be equal to 5. We get similar points because of the symmetry. Let us join these points. What we see is that when f of x is transformed to f of x plus 1, the whole curve got shifted upwards. And we can clearly see it got shifted by 1 unit. Now let us consider g of x to be equal to f of x minus 1. That is, k value, let us take it to be equal to -1. Let's see what happens. Various values of x, let us find values of g of x. For x, let us see corresponding values of g of x. Consider x to be 0, we get 0 square minus 1, minus 1. So we have the point 0, -1. So you get somewhere here. For x equal to 1, we get 1 square minus 1, 1 minus 1, which is 0. So you get the point 1, 0. For x equal to 2, we get 2 square minus 1, 4 minus 1, which is 3. So for x equal to 2, we get it to be equal to 3, somewhere in between. Yeah, between 1 and 4. So similar points we get because of the similarity, because of the symmetry. Because of the symmetry, we get points to both the sides. Join them. What we see is that the curve f of x is shifted downwards, again by 1 unit. Now let us make an observation. This is the curve f of x plus 1. This is the curve f of x minus 1. When we transform f of x to f of x plus 1, we see that it is a vertical translation. It gets translated vertically upward by 1 unit. When it is f of x minus 1, again we see a vertical translation, but it gets shifted downward. So we can conclude that when f of x is transformed to f of x plus k, we end up getting a vertical translation. A vertical translation. Now the translation is vertically upward. The translation is vertically upward if k is positive. And the translation is vertically downward if you get k to be negative. Once again, if the function f of x is transformed into f of x plus a constant k, it's a vertical translation. If k is positive, the whole curve gets shifted upward by 1 unit, by k units. If k is negative, the whole curve gets shifted downward by k units. I would like you to explore the same kind of transformation by considering various values for k and make an observation, verify this result. Thank you.